So good afternoon to
All of you. Is my voice is audible to all of you?
good afternoon to all of you.
Is my voice audible to all of you? Is my voice audible to all of you? Oh, fine. So today we are going to talk about the classification of the cement. So we have started this topic. So today is the last class of this one, classification of cement, or something is left. I will finish by tomorrow. Then we will go to the switch over to the aggregate part, type of the aggregate. So first of all, I will discuss about the ASTM classification. That is generally it is called as C150. So ASTM, American Society for Testing in Material, they have classified the cement under the category of C150. So they have classified the cement up to five category. So this is type one, that is general for that is generally used for general purpose. So basically we call this one as OPC. So that is basically called as ordinary Portland cement. Type 2 is called moderately sulfate resistant and moderately heat of hydration. Okay. So type 2 is the cement which is not available in our country. Type 2 is generally not available in our country. That is moderately sulfate resistant and moderate heat of hydration. It is in between this one. Okay. And type 3 that is generally used called high early strength. In India, we called it this one as rapid hardening cement. That is rapid hardening cement. And type 4 is called low heat of hydration. In India, this is called as low heat cement, LSC. And type 5 that is called sulfate resistant cement. This is called SRC, sulfate resistant cement. So in India, basically we have four type of the cement that is called rapid handling, low heat cement, sulfate resistant cement, and ordinary Portland cement. And there is some special category of cement that is called type 1A and 2A. That is type 1A and 2A. That is called air entrant cement. Air entrant cement. What do you mean by air entrant cement? Let me tell you. Air entrant cement. What do you mean by? So, entrant Portland cement is a special type of cement which we are injecting some air bubble by using some chemicals. By using of some chemicals, we are injecting the air bubbles into the cement. For what purpose? So it will actually protect us from the environment which is subjected to thawing and freezing. Whereas there is change in temperature is there is change in temperature, there is thawing and freezing. Because of thawing and freezing, volumetric expansion will be there. Volumetric expansion of the cement is there. So in order to avoid that one, we are actually entraining air bubbles or injecting the air bubbles into the cement. Okay, so that is the purpose. What are the advantages? What are the advantages you see? Advantage of air entrant cement is to increase the workability of the cement. We can, what do you mean by workability, I will discuss later on, but to increase the workability of the cement. Okay, and by using air entrant cement, so what will happen, the effect of throwing and freezing will minimizes, or the effect of freezing and throwing is reduces, and blending and segregation of the concrete will reduce. Okay, segregation means separation of the coarse aggregate from the cement. Bleeding means the rise of the water from the concrete. So that will also reduces. And air entrant air improves the sulfate resistance capacity of the concrete. Where the environment, where the soil is containing sulfate chemicals, if you use this type of cement, then it will also improve the sulfate resistance capacity of the concrete, and reduces the possibility of sinkage and crack formation in the concrete surface. So this is the basically the advantage of the air entrant cement. So now, so type 1, type 2, this is a special type of cement. So in India, that is, we are available type 1, type 3, type 4, type 5. Type 2 is generally it is used or available, that is in foreign country, American country, that is generally they use this type of cement. Okay. Next, yes. What are the typical composition of the cement? I already told you, when we are going for the hydration reaction, when you are going for the hydration reaction of the cement with water, some of the complex compound will form. Some of the complex compound will form, that is C3S, C2S, and C3A and C4A. And these are not simultaneously, they are not formed. They actually form one after another. Okay, one after another, they will form, and they will take periodic time. They will take some times to form. So C3S and C2S generally responsible for heat, responsible for strength parameter. C3 and C4A generally responsible for heat of hydration. So first one, this type 1, that is, I told you, this is ordinary Portland cement. That is generally more than the C3S is predominant. C3S amount is predominant. That is generally available more than 50%. So that generally available 45 to 55% of C3S, and C2S is also available around half of that one, that is 20 to 30%, or that is half of C3S generally available C2S, and C3A and C4Fs 8 to 12%, and 6 to 10% of C4A. But type 2, that is moderately sulfate, moderately heat of hydration cement, type 2, that is generally that C2S, the C3A is minimum, because the heat of hydration is less. Because heat of hydration is less, so C3A amount is less than as compared to the ordinary Portland cement or type 1 cement. And type 3 cement, I told you, rapid hardening cement. For rapid hardening cement, which parameter is to be predominant? Strength parameter. So that is 50 to 60% of C3S will be must. Okay, if C3S is increases, C2S must be decreases. Okay, if C3S is decreasing in cement, so to balance that one, C2S will decreases, and if C3A is increases in the cement, to balance that one, C4AF will decreases. So this is the balance. So here C3S amount is increasing, so C2S to be decreased. And rapid hardening cement means we are gaining the strength of the cement is very fast. So how we can gain the strength of the cement very fast? By increasing the fineness. By increasing fineness of the cement, if you grind the cement to very fine clinker particles, then you can able to gain the strength of the cement very quick. So if you increase the fineness of the cement, the heat of hydration also increases. The heat of hydration of the cement also increases. So here you can see the heat of hydration also of the cement is increasing. 8 to 6 to 7%. So C3S is the predominant constituent in rapid hardening cement. That is, this one is rapid hardening cement, or that is type 3 cement. Okay. Type 4 is called, that is in India, that is called low heat cement or type 4 cement. Here the heat of hydration is less. So here C3S amount we are minimizing. Here we are increasing the C2S. C2S we are increasing for less heat of hydration. Okay, there is for less heat of hydration, for the low heat uh, evolved from the cement, this reaction, they are increasing C2S as compared to this. That is the only difference. And type 5 what I told you? Type 5 is sulfate resistant. Sulfate resistant the cement, just you remember, this is the cement we are manufacturing by minimizing the C3A content. By minimizing the C3A content, we are actually manufacturing the type 5, that sulfate resistant cement, SRC, that we are talking in next topic, next subsequent course of our lecture, that is sulfate resistant cement. We are minimizing the C3A content. So this is the basic characteristic. Now actually I am briefing this one in short notes. So type 2 that is moderately sulfate and moderately heat of hydration, that is actually lower C3S and C3A. Okay, C3A and C3A amount is less as compared to the ordinary Portland cement. Okay, type 3 is called rapid hardening cement. The type 3 rapid hardening cement where C3S constituent is very higher. C3A constituent higher, and we are actually grinding the clinker to very high degree of fineness. We are grinding the clinker to a very high degree of fineness, so that the heat of hydration will be increases. So the gaining of the strength will be very fast. So the strength gain will be very fast in rapid hardening cement. But one thing you have to take care of that one. If we are gaining the strength very fast, so what will happen? We are actually allowing the possibility of thermal cracking in the cement is more. Okay, where there is no definitely there is no doubt we are gaining the strength is very fast, very quick. But as the degree of fineness is increasing, heat of hydration of the cement also in rapid hardening cement also increasing. So as a result, we are actually allowing the cement to have a very high possibility of thermal cracking. High possibility of thermal cracking. So as a consequence, the durability of the structure will decreases. As a consequence, the durability of the structure will decreases. Okay, so that's why you can imagine the old building, old temple. Now you can see the crack. There is no cracks are formed. There is no thermal cracking, or there is no possibility of failure of the old structure. But now you can see some of the structure which are designing very fast, very quickly. If you're not going for the periodical maintenance of the structure, then there we are allowing the structure to be collapsed. If you not go the properly maintenance, you do not take care of the structure, so that the structure will collapse. That is the rapid hardening cement. The heat of hydration will very high. As a result, what will happen? We are actually thermal cracking will develop. As a thermal cracking will develop, then the durability of the structure will decreases. So type 4 is the cement, that is low heat cement. Type 4 is the low heat cement where the we are actually lowering the amount of C3S, but we are increasing the amount of C2S. We are increasing amount of the C2S. So here the C3S and C3 amount is less as compared to type 2. Moderately sulfate and moderately heat of hydration. So there is the constituent here. The predominant constituent in low heat cement is C2S. Where increase the C2S amount is more. So as a result, as the name itself is low heat. Low heat cement means the heat of hydration is very less. Okay, so the strength in low heat cement, the gaining of the strength in low heat cement is gradually. Okay, it will gain the strength if you are using the cement in structure. So the strength gain is gradually and it is continuous in manner. So there is no possibility of thermal cracking, and the durability of the structure increases. And the durability of the structure increases in low heat cement. That is the thing. And type 5, the sulfate resistant cement, SRC, sulfate resistant cement where C3A content is, we are actually lowering the content of the C3A. Okay, because if you increase the C3A content in the sulfate resistant cement, then it will be very dangerous. So we are getting the sulfate resistant cement by minimizing the C3 constituent, okay, alumina constituent. So this is the basic difference. Now actually there is a comparison of heat of hydration and the compressive strength. Okay, this is the graph. I think it is visible to you or not. Let me zoom this one. I think now it is visible. So this is the, you can see this graph. Here, in one axis I have taken, the heat of hydration, another axis I have taken this edge in days. So you can see the type 3 cement. Type 3 cement is which one? The rapid hardening cement. The rapid hardening cement, first you see the type 1, okay, type 1 cement. The gaining of the strength is initially it is increasing. After that it is gradually decreases. After 90 days, it is completely the heat of hydration is very less. But you see the type 3 which is rapid hardening cement, initially the heat of hydration is very high, 80 calorie per gram. 80 calorie per gram is very high. Now it is increasing very fast, very quickly. Now it is almost approaching the asymptotic in nature. Means one, there is no heat of hydration is after that one. Okay, but you can see the type 2. Type 2 is low heat cement. With the low heat cement, the heat of hydration initially is very less, but is progressively increasing. It is progressively increasing gradual manner and is continuous to extend. So what is indicating if the heat of hydration is gradually it is happening, we are actually allowing each and every constituent of the cement particle to be in the chemical reaction. Okay, so every each and every constituent of the cement particle are actually going for the chemical or exothermic reaction or heat of hydration. That's why the strength we are getting high. But rapid hardening cement, the one advantage is that initially will get very high strength, but it is the durability of the structure later on, after some period of time, it will decreases. So this is the now you can see this graph. This is the compressive strength in one axis, y axis is we have taken, and the time we have taken in 5-year period. 5-year period we have taken. So you can see here the type 1 cement. This is the type 1 cement. The compressive strength is we are actually increasing with respect to this time, and after some period of time, it is asymptotic. There is no further that much increase in strength of the cement. So now, but type 2 and type 4, which is moderately low and moderately sulfate resistant and low heat cement, where you can see the gradual increasing in the compressive strength of the cement, gradual increase. So the strength of the cement is gradually increasing. So where you can see type 3 is the rapid hardening cement. The rate of gain of strength is very high, but after some period of the this is 90 days, almost the strength is asymptotic in nature. There is no further increment in the strength of the cement. So low heat cement, the initial strength, low heat cement, if you are using any structure, initial gain of the strength is not that much. But if you wait for some particular long period of time, okay, we are waiting for long period of time, then the strength gain is gradually. That's why actually in the massive mass construction like dams, barrages, so we go for the low heat cement. We are not, if you use the rapid hardening cement in dams or in barrage construction, what will happen? That some thermal cracking will develop, thermal cracks will develop. So in dams and barrages, there is periodically maintenance is very difficult. Okay, very difficult. So that's why you are, if you see about any bridge construction, dam construction, so that is, it will take some years, long years, 2 years like that one for the construction. So there we are using the low heat cement for the construction purpose. But you can see in the road design, the road construction, there you cannot wait for the traffic to be stopped for a very long period of time. So there we can go for the rapid hardening cement because the construction to be finished with a stipulated time. Okay, that is the thing. So one thing you remember in rapid hardening cement, you just remember this point. In rapid hardening cement, if we are actually increasing the fineness of the cement. If the fineness of the cement is increases, the heat of hydration of the cement increases, and thermal cracking, minor some thermal cracking of the cement also increases. But in low heat cement, what will happen? The heat of hydration is decreases. Heat of hydration is decreases. Heat of hydration is decreases means we are actually minimizes the possibility of the thermal cracking, and minimize the possibility of the thermal cracking. And there is the initial strength is very high, initial strength is very high, but here the rate of strength of gain is gradual in nature, but it will continuous in nature. It will, we are not gaining the strength, initial period is very high, but here the gaining of the strength is gradually, and it is increases in like this gradually, it is continuous in nature. But in rapid hardening cement, you can see initial strength is very high, then it is almost asymptotic, and further there is no significant increase in the strength of the cement after 90-day period. Okay, so that is the difference I was talking about. So next, the blended cement. So blended cement, what is blended cement? Let me talk about. Blended cement is that blended cement is not there. Okay, no problem. Okay. Blended cement means we are blending some ingredients into the cement to form some other kind of cement. Means we are blending some other ingredients like slag. This is slag we are actually blending into the ordinary Portland cement to produce Portland blast furnace slag cement. In India, that is called PSC, Portland slag cement. That is called type 1S. That is type 1S. In Portland blast furnace slag cement, almost slag is 25 to 70% by mass. Okay. And second type of blended cement is that is coming out of the ASTM C595, Portland Pozolanic cement. Portland in India it is called PPC. In India it is called PPC, and this is type 1P, where pozzolana content we are using 15 to 40% by mass. Now we should understand what do you mean with slag and pozzolana. Slag is a hydraulic cement. Okay, slag is a hydraulic cement which reacts on its own with water, and it can also form its compound, reacting compound it will form. But pozzolana is blended material which cannot react by its own itself. It cannot react. When it will come in contact with the cement, then it's activate its reaction, and it will react. Okay, so what is blast furnace slag? What do you mean slag? So slag is so you can see that what is slag. So what is slag? So slag cement, or that is called granulated blast furnace slag, has used in concrete projects different United States. Okay, different United States that is they are using. So this is blast furnace slag, wherein iron ore manufacturing company, there is a waste product we are actually getting, that is called slag, and that slag has a cementitious property. It will react with water and produces on product. But when we are using this, when you are replacing this cement, we are replacing the cement by slag. Okay, so it has also different advantage property. What are the properties? Are using this slag cement replace portion of the Portland cement in concrete mixture is useful method to make concrete better and more consistent. Among the measurable improvements are better concrete workability. We can increase the workability, and this is higher compressive strength and flexural strength as compared to ordinary Portland cement. Lower permeability. Lower permeability means the degree of porosity is decreases in this concrete structure, and improved resistance to aggressive chemical environment. Okay, the more consistent plastic and hardened properties, and lighter color. Okay, so that is when iron is manufactured using blast furnace. The furnace is continuously charged from the top with oxide, fluxing material and fuel. Two products, slag and iron, collect in the bottom of the hearth. Molten slag floats on the top of the molten iron. Both are tapped separately. Okay, so that is called molten iron sent to the steel producing company, but the slag which we are getting, that is generally used for the cement manufacturing company. That is the difference. So you can see the construction of west campus of the hospital side, that they are actually using the blast blast furnace slag cement for its construction. The very advantages, and we are replacing the cement. We are decreasing the cost of the cement. We are using slag as a replaced product of the ordinary Portland cement. So we can say the blended cement means 70% slag we can use, 75%, 25% clinker we can use. Okay, then that can we can use and we can manufacture our cement. Okay. So that is the advantage we can get. That is the advantage we can get of this blast furnace slag cement. Means in blast furnace slag, if you want to use the blended cement, you can use 75% of the slag, 25% of the clinker, and 5% of the gypsum. If you want to use the Portland blast furnace slag cement, you can take 75% of the slag, okay, from the iron manufacturing, and this is 25% of the clinker, cement clinker, and 5% of the gypsum, and you can actually produce the PPSC, Portland blast furnace slag cement. Second type the blended cement is called Portland pozzolana cement, that is PPC, where the pozzolana content is 15 to 40% by mass. So pozzolana is a material which actually cannot react by its own itself. It's when it will come in contact with cement, then it activates and it will produce some cements, calcium hydroxide gel, CSS gel. Okay, so that is the difference in between this one. So so in the presence of the cement slag, okay, in the presence of the cement slag, get activated and react much faster. Okay, so slag, I told you, it will react by its own self, but when it will come in contact with cement, it will activate and it will react very fastly. Okay, and the strength is much more than ordinary Portland cement. But on the other hand, pozzolanic material cannot react on their own with water. They cannot react. They need the presence of cement, because cement generates calcium hydroxide upon hydration of lime, upon hydration. Because the when the cement will react with water, it will produce the calcium hydroxide gel. This is called calcium hydroxide silicate, calcium hydroxide silicate gel, and this actually if further used by this pozzolanic material, okay, further used by the pozzolanic material for its reaction purpose, and it will gain the strength. So when you use this pozzolanic material or replace material with the ordinary Portland cement as a blended cement, the pores of the structure will reduce. The degree of porosity or degree of porosity of voids in the structure will minimizes. As the degree of porosity or voids will minimizes in the structure, so what you can, it means we can say the durability structure increases, because if the structure will be highly porosity, the water atmospheric moisture will enter into the structure. So what will happen, there is some actually expansion temperature due to temperature change in temperature, there is expansion of the cement will occur. So there is some thermal cracking will form, there is some minor small cracks will form. So if you can reduce the force of the structure, ultimate thing we can say, the durability of structure will increases. So that is the blended cement. What blended cement are two types, that is Portland blast furnace slag cement type 1S and Portland pozzolanic cement, that is type 1P. So you can see this graph. What is the advantage of the pozzolana? You can see here. So in this graph you can see, so here the heat of hydration I have taken in y-axis, and in other axis I have taken the pozzolana content. On the other hand, I have taken the pozzolana content. So if we are increasing the pozzolana content in x-axis, now you can see the heat of hydration is minimizes. Okay, if the heat of hydration is decreasing, mean there is we are actually stopping, we are prohibiting the formation of the thermal cracks. Okay, we are not allowing the formation of the, or we are not allowing it to form the thermal cracks in the structure. So if you increase the pozzolana content, the heat of hydration is decreases. Okay, now you can see this one. Okay, this is the thing. This is the expansion of the cement and curing periods. Expansion of the cement curing. If you use this pozzolana content in the cement, the volumetric expansion of the cement is also decreases. The volumetric expansion of the cement also decreases. By using pozzolana 20%, you can see this one, 30% this one. Okay, so when there is a alkali means alkali aggregate alkali aggregate reaction will happen, so there will expansion in the cement will happen occurs. So if you use these pozzolanic materials, okay, pozzolanic material. What is the pozzolan generally you are using in the cement? That is called fly ash. That is called fly ash. That is called, generally we are using fly ash as our pozzolanic material, or in other country also they are using some other constituent like that is what is the pozzolanic material, this fly ash and calcinite clay. Okay, these are the pozzolanic material they are actually using in other country. Okay, so that is the thing. By using pozzolana, we can minimize the heat of hydration. Okay. So other countries we are using what is calcined clay. That is calcined calcined clay is our pozzolanic material. But most of the country in our India we are using fly ash as a pozzolanic material. So here also that expansion of the cement also decreases if you using the pozzolanic material. So we can say the expansion, volumetric expansion also decreases by using pozzolanic as a blended cement, blended compound in the cement, and also heat of hydration also we are minimizing. So this is the we need to know. This is the we need to know. This is the required for us. That is called Bureau of Indian Standard Classification. That is called Bureau of Indian Standard Classification, and that is referred in our country. That is India. Okay. So they have categorized our cement into 4 types. That is called ordinary Portland cement. Ordinary Portland cement. So that is you can refer this code IS code IS 269 1989. And this ordinary Portland cement further classified into 33, 43, 53 grade. Ordinary Portland cement further it is classified into 33, 43, 53 grade, and this grade implies the compressive strength achieved by the cement mortar in 28 days. Okay, at 28 days, what is the compressive strength? Compressive strength gained by the cement mortar, that is. So if you talk about the 33 grade of the cement, the compressive strength at the 28 days period, that is 33 megapascal. Okay, if you talk about OPC 43, so compressive strength at 28 that is 43 megapascal. So that is, and if you talk about 53 grade, that is compressive strength is 53 megapascal. So what is the difference between 33, 43 and 53? So 53 megapascal has higher compressive strength, and there is heat of hydration is very high, because um, high strength means higher heat of hydration. So this is low strength, low heat of hydration. Okay. Second type of cement, that is called Portland cement, or that is called low heat Portland cement. Okay, low heat Portland cement, low heat cement. That is the IS classification IS 12600 1989. Then rapid hardening Portland cement RSC, rapid hardening Portland cement, that is IS 8041 1970. Then this is PPC, Portland Pozzolana cement. Pozzolana is what? This is we are using fly ash. Fly ash as pozzolanic material in our country. This is 1976. And this is blast furnace slag or Portland slag cement. That is IS for this one. You can refer this one. Okay. So IS 4597, and this is the slag generally you are actually finding it from the iron manufacturing company. iron manufacturing company, we are getting the slag, and this slag generally we are using as our cement. So in next class we will talk about this Bureau of Indian Standard classification in detail, some of the classification, and we can also talk about the cement where we are using, where actually we are going for the Portland cement, low heat Portland cement, low heat Portland cement, where we are going for the rapid hardening cement, where we are going for the PPC, Portland pozzolana cement, we are going for PSC, Portland slag cement. Okay, so we are going to look into this one in detail in next classes. Okay, so I hope this classes is help to you all of you. So thank you all and have a good day. Okay, thank you all.